Just always using test form.
No, I only do just the test, so you don't have to worry about missing lecture. You can take the test through the class time, because I don't do any lecture, it's just the test. So you won't be missing out on anything. If you take the test and don't get to class, I don't lecture, just the test. Obviously, if you have any trouble with your basic multiplication tables, you're not going to be able to do that problem. And you're going to have trouble forever. So, that's a really good place to start. You can come see me, you can go see a tutor. You've got to know stuff immediately. What's 7 times 8? You should know it. Don't be reaching for that calculator. What's that?
Yeah.
That's 76. 7 times 8? 56. Cool. I like it. The more you know that, the easier everything is. It's crazy. So there's several ways to start this off, but somebody give me one. How did you do it? So you did like, all right, one way to do it is 10 times 72.
Yeah.
Right? Because it ends in 0. Then 10 is, and what you can always do, if you're not sure, if it's even, you can just keep dividing by 2 until you can't anymore, and then you got to think about it. So like here, I could do 2 times what is 72? Maybe not. Okay. 36. And then 2 times what is 36? 18. And then 2 times what is 18? 9. Oh shit. And then 9 is?
3 times 3.
Good Lord, man. So 720, let me collect all this stuff together. Let me put it down here. Is 2 times 2 times 2 times 2 times 3 times 3 times 5. And I don't think we've officially talked about exponents in. Did we talk about exponents yet? Not really. But it's a way of collecting stuff that are multiplying. So this would be 2 to the 4th. 3 to the 2nd. Just a quick way of telling people I got 2 3s. Don't make me write them out. I got 2 of them. Don't make me write them out. I got 4 of them. I mean, that's what exponents really are. That's all they are. So if you just write it like that, I'm fine with it. That's a way to write it more compact. Is that familiar? If you took a different route, I don't care. You're going to end up here. So if you started with like, what? 9 times 80? The 9 is 3 times 3. And then 80 is going to be the rest of this. So that's why I call it the DNA. It doesn't matter how you slice it up. It's going to be the same parts at the end. I like it. Cool. Okay. Let's see. Oh, okay, good. We are going to get into fractions eventually.
Yeah.
I know. You don't have to tell me. I know how you feel about fractions. But to kind of go in that direction, there's something called the least common multiple, which is just actually another name for least common denominator. Trouble with that word. Denominator. Exactly, right? So really break this down. The smallest thing that both numbers multiply up to be. So this is more general than least common denominator. It could be just 2 numbers just sitting somewhere. They don't have to be below. They don't have to be on the bottom. So like if I'm going to show you a really cool way to do this. And I know only a math teacher would say something like that. So if I wanted to find the LCM for those 2 numbers. Now watch this. I like the way you're thinking. I could first start with the biggest number that goes into both. What is the biggest number that goes into both? 8. Do you guys see that? This is 8 times 7. This is 8 times 10. So write that. 8 times 10. 8 times 7. Now to build it up, I'm trying to multiply it up so that they both are the same number. So if it was the numbers 3 and 4, that's really obvious. What would be the number they both multiply up to be? 3 and 4? 12. 3 and 4 can both become 12. That's the smallest number they can both become 24 also. But I want the least. So this is a really cool way to do this. If you break up the numbers using the biggest number they have in common, what is this guy missing that he's got? Do it again. No. Be very specific. What is he missing that he's got? What's he got? He's got an 8 and a 7. He's got an 8 and a 10. So what's he missing that he's got?
10 and 7.
He's already got a 10. What is this guy missing that guy has? A 7. Is everybody cool with that? Do you guys see that? He's not missing a 10. He has a 10. You're getting ahead of me maybe. That's what he's missing. What's he missing that he's got? A 7. What's he missing that he's got? A 10. Do you see how now those are both the same number?
Yes.
And that number will be the least common multiple. You built them up to match. When you break it up according to what they already have in common, that's going to guarantee that it's the least. If I can just multiply them together, that's going to be a common multiple. But that's not the least common number. It's not the lowest common denominator. I can actually say the word denominator. I just like to play with it. Just in case you guys are like, my teacher can't even say the freaking denominator. All right. And then what is it? What's 8 times 7 times 10? 560. That's the lowest. That's the least common multiple of those two numbers. That is one way to do it. Another way is just to start listing multiples of 80 until you match a multiple of 56. That would drive me insane. But if you're able to keep your sanity and do that, you could. Yes?
Can you do one more example?
Sure. And this is a beautiful, really quick. Really quick. I want to show you. This method I'm using, maybe it'll be more interesting if I give it to you as a fraction. Go with me. Go with me. Go with me. All right, let's say I had to add those. Oh, that sucks. Because exactly, got to find that LCD, and I've given you a way to find it easily. What number does 77 and 21 have in common?
7.
7. So 77 is 7 times. Oh, thank heaven. 711. And 21 is?
7 times 3.
Now you just give them, because you're allowed to give them a number now, because as long as you do it to the top and the bottom. I know I'm getting a little ahead of myself, but I know you all hate fractions, which means you must know something about them. So you gave that away. Which is I have no opinion about it. What is he missing that he's got? 3. So multiply top and bottom by 3 to make it legal. What is he missing that he's got now? 11. You stop there for a second. Yes, ma'am? Say again? Because he's had this. What does the other guy have that he doesn't have? 3. If you really think about it, that's what you do with the simpler fractions like this. What do you do here to make them the same?
Divide.
How do you make that the same as that? Multiply by 3, because 9 is 3 times 3. So you give him what he's missing according to what the other guy has. So this one I'm just doing it both at the same time. It's like if you have kids, and the kid comes up and he's got more ice cream. All right, now he's got more. I would just eat all the ice cream, so it's probably good that I don't have kids. But you're giving them what the other one doesn't. He's got sprinkles, okay. He's got chocolate, okay. He's got the number 3, okay. He's got the number 11, okay. But now are they both the same number on the bottom? Yeah. That's the whole point, isn't it? And it's actually the lowest number that they could both become. So on the top I would get 9 plus 55. Now what's 3 times 7 times 11?
231.
Yes, 231. All right. So you get 64 over 231. Cool. All right, I know I got a little ahead of myself, but it's nice to see this idea used where we use it the most, which is finding LCDs. I don't know, has anyone ever seen that method for finding LCD before? If there's small numbers, you don't need this. This is like too much for, if I had 6 and 8, you should be able to figure out what the LCD is. But for these uglier, bigger numbers with more stuff inside them, that's a beautiful way to do it. Yes, ma'am.
So if you have, like, the problem is 80 and 56, can you do it as a fraction?
Totally. So if I had 7 over 80 minus 1 over 56. So now we figured out this guy needs a 7. So we'd multiply him. I mean, you do all this work down here just like we did here, but we already kind of did it. This guy needs a 10. So now they're both 560 on the bottom, right? 7 times 80, 56 times 10.
But if, like, say you just have those, what would you put on the top?
Oh. The reason this is a little weird to me is I'm not allowed to just multiply a number by 7, but to find the LCM for these, I have to do this. It's not like I'm, in a fraction, I've got to do the same thing to the top and bottom so the fraction stays the same. The purpose of this problem is to find the number that would be the LCD if those were on the bottom. So if it is a fraction, you got to be careful and make sure that you're doing everything legally. Here, it's not really fractions. You're just, what would the fraction have on the bottom? 560. I like the question, though. You're right. That's why I like it in this context better. Because then it's like you actually have the rules on top. You got to multiply top and bottom. Yeah. Yes.
So for the division problem, for the fraction problems, you pretty much multiply the top to the top number, whatever it is that it means, right?
Yeah, whatever you multiply the bottom by. Yeah. And how do you know what to multiply the bottom by? According to what it needs. Yeah. You better do the same to the top. Because what did I just multiply by? 3 over 3. Well, what is 3 over 3?
1.
And I'm allowed to multiply any damn thing I want to by 1. Because nothing really happens. So I made this fraction look, this is what's really freaky. I made this fraction look different, but it's the same number. Right? 1 divided by 2 is the same number as 2 divided by 4. They're both 0.5. They're just different ways to represent it. That gets people a little freaked out, but it really shouldn't. Okay. That's related to like reducing fractions, right? But that, again, I'm doing too much fractions. We're not to fractions yet. Okay. Let me think. I think that's almost everything I wanted to do. Because that's the end of chapter 2. That's why I want to make sure everybody got 3-5 homework to work on.
Jeff, can you give me the rest of the
Just to remind you guys, I think we already said this several times, but that test is on the 15th.
Jeff, can you give me the rest of the
Say again? Oh, I got some other ones here. Where did I go? Oh, I think I gave them all away. Shit. I got to go print some more out for you. That's right, because you weren't here when I was giving them all out. I think, right? I got to print some more out for you. Yes. I'll give you the rest. Yeah. All right, guys. What I'm trying to do is let us out a little early. That's what I'm attempting to do. We're to the end of chapter 2. Are there questions on what we just did that you have at the moment? This is this kind of stuff that you just got to get into. You got to get into the homework and see what little freaky problems there are, and then come with questions. I live off of that. We got a nice long weekend. Monday, take Monday off from the rest of your classes. Tuesday, we'll be back here.
I need 2.1.
I got to print it.
Put it back, okay?
I got a question.
You want this?
So a couple things. You're thinking least size. This doesn't exist, but like least common divisor would be the smallest number that goes into both. Least common multiple is the smallest number that both become multiply up to be. You see what I'm saying? So I understand what you're saying, but that we would say like greatest common divisor is 8. That's the biggest number that goes in the both. Least common multiple is the smallest number they could both multiply up to be. I like it though. So least common divisor doesn't really, we never really talk about that because it's not useful, but that's what it would be for 2, yeah. Cool. Right. Here? Yeah.
Yeah, I did the wrong one.
Uh-oh, shiesty.
What?
You did the wrong assignment?
I did.
I don't understand. What do you mean?
It's not. It's because it got from the library book.
Oh, okay. Okay.
I did extra.
Good. Yeah.
Good exercise for your brain. Yeah, right. You're getting so.
We plug it 3 in. And you, alright, let's see. No. It says that home is 3. So wherever you see a V, you're going to plug a 3 there, right? If I said, what is this if A is 7 and B is 2? Yes, the question doesn't say solve it, it just says check to see if this is a solution to it.
So how if we're not solving it, actually, just put a yes or?
Exactly. Because the answer to the question is this a solution? So if it is, you just say yes.
And if not, say no.
And if it's not, say no. Somebody said like just yay or nay, I'm like, exactly. Show me the work. And then you just say yes or no.
I would say no.
Yeah, if it comes out to be not true, look, if it comes out to not be true, you say no.
So no to both of them.
Maybe. It could be.
But still show the work.
Yeah.
Totally yes. Don't just say yes and no. I gotta see why you say that. Yes.
Jeff?
No.
Because you could just guess and get lucky.
Yeah.
I gotta see what work you did. Okay?
Okay, so one more question before I'm out of here. So the whole papers should be done till Tuesday?
You've got you don't have to do every single problem. You know that, right? You've got the homework sheet, right? So you don't have to do those, what I assigned. Okay, good. Yeah, I don't know what it is for each one. Like the first one was every 4th one. Oh yeah, thank you.
The fourth one, right?
The first was every 4th one, and then the next, some of the rest are every 3rd one. That's homework, yeah.
How about the correction homework?
Same pile. It's my big pile of stuff to do.
Yeah, well, I staple them separately.
Oh yeah, you.
Kept it like
You have a
you said.
stapler?
Yes.
Well, see you later,
Thank you.
sir.
Hey.
Can somebody grab my camera? Thank you. Poor little dude. Turn him off.